In exercise 106, we're going to stay with the idea of looking at the value of an item. Now, in 105, we saw how to calculate the value of an item if it's increasing. In 106, we're going to look at the value of an item that is decreasing in value. Now, an item will decrease in value in one of two ways. So you'll look at this concept called depreciation, which is a decrease in value, appreciation, increase, depreciation, decrease. Like I just said, there are two methods for calculating depreciation of an item, and that covers exercise 106 and 107. The method that we're going to use in 106 is called the straight line method. Now, hopefully when we say those words straight line, you're thinking a graph and a straight line. And in algebra, we saw the equation of a straight line. And the equation for all straight lines can be written in the format y equals mx plus c. You're going to see that to calculate the value when an item depreciates, we're going to use a very similar formula. It is obviously the equation for a straight line, but it looks a little bit different to our y equals mx plus c. And just introducing some terms that you need to be aware of. There's a term called the salvage value. We use the symbol S in the equation to represent the salvage value, and what that means is it's the value at any particular time. S is the value at some particular time. We have another value that you have to be aware of, and that's called the initial value. So initial is in the beginning. When you first buy some items, when you first buy an item, it's called its initial value, and for some items, their value decreases. The symbol that we use for this initial value is V with a little 0. Now, I think that symbol is very relevant because V stands for value, we understand that, and the 0 represents the time, at time 0, in the beginning, when I first purchased the item. So yes, that would give me the initial value. In order for us to have a situation where an item is decreasing in value, and we would apply the straight line method, is when the item decreases in exactly the same amount each year. Exactly the same amount. This doesn't in reality happen very often. For lots of things, lots of items, they decrease the most in the first year, and then after that they slow down. They don't decrease in value as rapidly. But there are situations where you can consider that the decrease in value is the same every year. So if you had an item worth $300 and in the beginning its initial value was $300 and it was depreciating at $100 a year, in 3 years' time it's worth $0. We don't go past that because it doesn't make any sense to say it's now valued at negative $100 or negative $200. So some of these equations are only relevant for a specific period of time, and we have to be really thinking about the situation for us to realise that it doesn't make sense to give the value as a negative number. Now you can see here that I have an example, and it says, what is the value of a $30,000 car which depreciates at $4,000 per year? Now that's telling us that it's at a constant amount each year after 2.5 years. Now, we could do this, we could answer this question with no reference to a formula. You know that we could calculate the total depreciation by using the information in the question, 2.5 years and 4,000 each year, so we multiply those two numbers and get 10,000. Now if we know that that is the total amount it depreciates over the 2.5 years, then we just take the 10,000 away because depreciation is a decrease, and we would get that the value of the car would be 20,000. Or you can see now that I've gone to the reference sheet, because on the reference sheet there appears a formula for the straight line method of depreciation, and it is S is V0 minus DN. The symbol S we've spoken about is the salvage value, the value of the item at a particular time. V0 was the initial value, remember, the value at 0 time. Take away, D is probably, as you could guess, the depreciation each year, and N is the number of years. So, whoops, that's better. If I go back to my situation where I worked out the value of this car to be $20,000 after the 2.5 years, I went back and I actually used now the formula, or S is V0 minus D, and dN means D times N. So our salvage value, our value at a particular time, is the 30,000 minus the amount it's depreciating, D is the depreciation per year, and times the N was 2.5. Now if you do that calculation, you will get $20,000. So you can see that, I guess in a way, we have options. We can use the formula, which is this method, or we can use our understanding. Some of you will find the formula easier, it's quicker, and knowing that that formula is on the reference sheet, of course, is a big benefit. Now, it's called straight line method because we could see the value of the car drawn on a graph. And if we drew the value of the car, so it's starting at time is 0, so our horizontal axis now is N, which is time, our vertical axis is S, the value. The red line is what we're focusing on. 30,000 was the value of the car in the beginning. Each 1 year we drop down 4,000, so from 30 we're dropping down 4,000 to 26. And keep in mind that a year is 2 units on that axis. If we go across another 2 units, which takes us across here, we've dropped down another 4,000. So if we plotted that line all the way down, we could certainly get a straight line. Now, what are the features of the straight line? We can see that line has a negative gradient. Where does that come from? If we take our formula and knowing that it is a linear function, now we normally write our linear functions as y equals mx plus c. M is the gradient or the slope. We can see that our line has to have a negative slope. So that is actually this component, this negative d, is our gradient. Our c, or where the line cuts the the y-axis, is our v0, is our c. And what they've actually done then, in fact, is they've written the straight line depreciation equation more in this format. And we know that the gradient of the line is a negative, and that's why we get that the value is the initial value minus the depreciation, and instead of x, we're measuring time, which is n. Now, like I said, this formula is on the formula sheet. However, this description doesn't appear on the formula sheet. So S is the salvage value after n periods, and it's plotted on the vertical axis. V0 is the initial value, and you can see that here is the 30,000. D, which is the gradient, is the rise over the run, which is a negative, tells us the amount that it's depreciating per period, and N is the number of periods. Let's have a look at example 14. Computer equipment is purchased for $28,000. What symbol are we going to use for our $28,000? We know that was the initial value, and so that is our V0 is 28,000. In the beginning, that's its value. Depreciation, our capital D, and that makes nice sense to use that letter, is $4,500. It says we have to use the straight line method of depreciation, so we don't have a choice here. We have to use that equation. And A says find the value, that's find S, when n is 3. So you can see I've written the formula. Well, I was told that I have to use the straight line method of depreciation. Start with the formula. That S is equal to V0 minus dn. Substitute in the appropriate values and take to your calculator, and you'll see the answer is 14,500. Some advantages of this are that you get your answer straight away. There's only one real line of working and one time you go to your calculator, so you're less likely to make the mistake. In part B, you're asked to find when. So find n to the nearest month, and I've actually noted that the equipment will be worth $11,000. Well, remember the term given to what an item is worth at any particular time is its salvage value, S. So I'm going to write up the formula. S is V0 minus D times N. We know S, so into this space goes $11,000. We're really using our algebra skills here. The initial price was your $28,000. It is still depreciating at $4,500 per year. In the formula, this N is measured in years. Now we're going to have a problem if we leave our answer in years because it asks for our answer to be in months. So we have to use our algebra skills now in order to make N the subject. You can see I've brought that term over to the other side and made it a positive, and I brought the two numbers together so they could be simplified. Then to get N by itself we divide by 4,500, remembering that N is going to be our answer in years. So we go to the calculator and you can see that it is 34 on 9. 34 on 9 years. Now, hopefully you all know that to convert years to months, you multiply by 12. Let's go back to the calculator. 34 on 9, multiply it by 12, and we get this many months. So you can see there, yeah, we're getting 45 and a third, and to the nearest month, that would be 45 months. 1/3's less than half, so we drop back. And in part C, they want to know when the item has no value. That's S is equal to 0. So you can see there that I have solved this equation equal to 0, got my answer in years and converted it to months.